I want to introduce to you Ron Bowes, lead researcher at Rapid7. And for the next session, he's going to tell us about from vulnerability to CTF.
Hello, everyone. Thank you all for coming. This is the first talk I've done to a live audience in like 3 years. So my only request is laugh and make jokes, because that way I feel like there's actually people around. I've been talking to a webcam for years, and it's been awful. So yeah, thanks all for coming. This talk is basically going to start off with me talking about myself, and what my background is, what I've done, what I do now, stuff like that. Then I want to talk about CTFs, capture the flag challenges. I've worked on CTFs in a bunch of different contexts over the years, and I think that a lot of them there's a lot of good things about CTFs that we can really learn from. Then the kind of point of the talk is I want to talk about vulnerabilities. I want to go over, I think, 5 or 6 or 7 vulnerabilities that either I found or I've known about, and I've turned into CTF challenges, and then sort of talk about the process of how I do that. And I just want to talk about vulns. I think vulns are cool, and I want to talk about them for an hour, and that's what we're going to do. And then I think I have one slide about what we learned, just to wrap it all up. So who am I? I am Ron Bowes. As our MC said, I'm at Rapid7. I'm a lead security researcher, which is a fancy way of saying I write blogs and work on Metasploit and stuff. My handle everywhere is YagoX86. Yago from Shakespeare, Othello, and x86 from the CPU. So you can find me on GitHub, on Twitter, on Steam, on pretty much every platform. Under that alias. So I wanted to share about my family first, just let you get to know me. I have a husband who doesn't like his picture public, and we have 2 birds together. They're both green-cheeked conures, GCCs, and because they're GCCs, we named them Clang and Sharp. So Clang on the left, we've had for about 2 years, and Sharp is brand new. We have him for like a month. Squawk, squawk. Thank you. They love joining my video calls and stuff at work. It's a lot of fun. They're little troublemakers, but I just want to show them off. Every CTF I make has them in there in some way now. So I've done a lot of open source development, and I kind of got my start doing like researchy stuff, working on Nmap. And Brandon, who's in the front row, me and him worked on Nmap together back in like 2009, 2010. And he dragged me to TourCon to do a talk in like 2011, and I got to talk about Nmap. And that was kind of cool. It's my first big talk. These days, I work on Metasploit part-time. I research vulnerabilities, stuff like that. I'll talk about that more. I've written tools for like hash extension attacks. Yeah, I do lots of open source work. I've done a DNS backdoor, DNS cat 2, so you might have heard of. My last 3 jobs, it turns out they're all kind of the same thing. In 2013, I moved to the States from Canada to work at Google. We would do, among other things, reviewing our own products, finding bugs in Google stuff, and then disclosing those bugs to the product teams, and they would fix them and stuff. Very much like internal. Then I jumped to CounterHack, which is run by Ed Scotus. It's sort of an affiliate of SANS. And at CounterHack, we would do pen testing for customers, which meant finding vulnerabilities in customer software and then sending those to the customers. And what was really cool about CounterHack is we would also do CTFs, which I'll talk about soon. And the vulnerabilities from customers would feed into the CTFs as like ideas for challenges, which is what this talks about. And then the trouble people had or the things people would find on the CTF challenges would feed back into our pen test business. So it's a really nice 2-way street, and that's what kind of gave me the idea for this talk. And then about, I guess in April this year, I started working at Rapid7, so I'm very, very new there. In Rapid7, I do all the same things. I take software, I find bugs and stuff. But now I just released it to the public. I can talk about it. I write blogs. I write Metasploit plugins. AttackerKB.com is where we post a lot of our write-ups. It's a really cool site, in my opinion, as an employee. But also, we do really deep dives on vulnerabilities. It's wondering if I can click on things. It's a pretty cool site. In terms of CTF, going back to like 2009 or so, I've been playing CTFs. Largely it's for Skullspace, which was our hacker space in Winnipeg, my hometown. And later on, I did DEF CON CTF with Stratum Orhur. Some of the folks from that team are here somewhere. So I've been doing CTFs as a player for a long, long time. And then I got started doing CTFs as a creator. So I make the BSidesLV San Francisco CTF, along with Brandon and Daniel and some others. My previous job, we made NetWars CTF, which is like, it's a paid thing from SANS. Again, me and Daniel worked on that together. And the Holiday Hack Challenge is a free thing that SANS and CounterHack would do every year. And that's a huge video game CTF, which we're really proud of. Again, me and Daniel worked on that. I should mention, I'm going to put a link to the slides on the last slide, so you'll be able to get them if you want them. I should mention, what is a CTF? CTF is a capture the flag challenge. Basically, if you don't know, there's multiple different kinds. I don't want to get into like the nitty-gritty things, but they're very short versions that players solve security-related challenges for points. Sometimes we just give them a question and answer. Sometimes they attack each other's like infrastructure. Either way, it's security challenges for points. And CTF time tracks a lot of the CTFs. Most CTFs, probably all of them. So I want to show off a little bit of history because I think it's kind of cool. The first CTF I did as a player was called Stripe CTF in 2010, apparently. And one big takeaway from that CTF was the final challenge was a hash extension vulnerability. At the time, I'd never heard of hash extension, ever. And the concept of it just blew my mind. And there was no tools for it. There was white papers, but no like easy to follow documentation. So I read the white papers, I wrote code, I hated it. It was really hard. I'm not very good at reading academic stuff. But I got through it and managed to write a proof of concept exploit for MD5, SHA-1, SHA-236, etc. And I made a tool called Hash Extender, and I wrote some blogs. And that's now like the best known tool for it. So I can really thank CTFs for giving me the idea to do that. I learned something I'd never learned before. The photos on the right are from a 2013 CTF called Plaid CTF. I just put them there because I like the story. The kid at the bottom right, hiding behind the recycling boxes, his name's Ethan. He's my buddy's kid. And he came with a cape on. And I said, "Why do you have a cape on, Ethan?" And he said, "I'm a dinosaur." And I was like, can't argue with that. So I think about 7 a.m. after working all night on the top right, I had a cape on. I don't remember why I thought that was a good idea, but I was also a dinosaur. So in 2010, as a hackerspace, me and Skullspace worked on Holiday Hack Challenge 2010. That was back when Daniel was an intern there. And we won. And Ed wrote, like, "You guys totally rocked. You did awesome. You're making cool stuff happen." And that was in March 2011. So it took 3 months to pick winners, which pretty much is how we always do it. What's cool, though, about this is that 2011, Ed told me how good I did. And then in 2017, I was working for him. So I'm really proud that I was able to kind of turn doing CTFs, especially doing them for like Ed, into part of my career. And that's like one of the reasons I like talking about this, is because like CTFs have done so much for me that I think it's really cool to talk about. This is the first CTF I wrote. This is my planning notes. I actually dug through my pile of notebooks and found this. And I wrote notes for how I want to make a CTF. And I don't want you to read all these. You're welcome to download the slides later and read them. But the funny thing is, I read through these, I'm thinking, oh yeah, I made this challenge again and again and again. There's a few things I really like making challenges out of. And as far back as 2011, I was still doing it. But the first big CTF I did was BSides San Francisco. And I'm almost done talking to myself, I promise. The story behind this was I met Reed Loden, who's somewhere at this conference. I don't think he's in the room. And we went out for lunch or something when I was in San Francisco visiting. And he said, "Hey, you know how to make CTFs. Do you want to do our CTF?" And I was like, "Sure." And we did it. And I recruited Brandon and Daniel and others to help make the CTF. And it ended up being like fairly successful. And we've been doing it for 5 years now. And each year is better than the last. So we do that every spring. I think we're doing this one in April. So it's really cool to get to do a big CTF, and I'm really happy that BSides San Francisco sort of gives me the time and trust. Reed basically says to us, like, make a CTF, let me know what you need, and then goes off and we do our own thing for 6 months and we make a CTF. It's pretty cool. So let's talk about why CTFs are valuable. I think I've touched on this a lot already, but I feel like I should do more than just talk about vulnerabilities, although I like talking about vulnerabilities. So this is the best open licensed image I could find to sort of, from an easy Google search, to say kind of like people learn a little bit of what they read and a lot of what they do, and then even more of what they teach. So CTFs are hands-on experience for things that people don't typically get hands-on experience doing. Like not everyone, especially people younger or new in their careers, are privileged enough to like be able to hack things like I've been able to as a pen tester or as a researcher or whatever. So like being able to teach people things and let them actually do and get hands-on work is super, super valuable. And bug bounties these days kind of fill that role too, but not gonna talk about those. Also with CTFs, write-ups are very much encouraged, and that's where teaching sort of comes in. For Holiday Hack Challenge, we would evaluate people based on their write-ups, not based on what they actually did. We would have 100 people finish it, or 1,000 people, I don't know the numbers, but a lot of people would finish it, and then would write us submissions of their solutions, and we would pick the ones that are our favorite technically and our favorite creatively. So this is just an example I found, not just from Googling around. He wrote this as a travel log, I believe, and it's really cool that people will then take the things they learned and share with others. And like, for myself, I would always write some of my CTF challenges as an author and as a doer, and I think it's really good to like really learn things. What I think is funny here is talking about is laundering, and no one told me I can't use this word, but it feels a little bit weird. But basically, as a pen tester, we often do work for customers, and they often have really cool bugs in their software that we can't talk about because they're customers. But feeding those bugs into like, what's the core of this bug that has nothing to do with the customer, but that we could teach people as a lesson so that when they see this bug, they'll find it. So I'll talk about some of those after. What's actually really funny about these is oftentimes bugs you find in real stuff are too simple or too silly to really be bugs you see in CTFs. People look and go, there's no way that would be a real bug. It's just too silly, but a lot of real bugs are that silly. And this is kind of a weirder concept. When I was young, and I had a couple of slides about this that I removed because I thought it was just too much talking about myself. It's already too much talking about myself. When I was young, I did a lot of video game hacking. 2017, 18, or when I was 17, 18, 19, I got really into Blizzard games and like wrote cheats and stuff for StarCraft and Warcraft 2 and Warcraft 3 and stuff. And like reverse engineering how those games worked and how the logins worked and how their protocols worked and how their anti-cheat worked and stuff. I learned a lot as like a 17, 18, 19-year-old. And those systems don't exist anymore. They don't use those same logins anymore. So being able to share those with others and say like, here's where I learned how to do this. Here's where I cut my teeth. Here's what I thought was interesting. And being able to wrap it up into a challenge is really cool. So I feel like I'm kind of honoring the vulnerabilities by showing people kind of how they worked. We'll talk about a couple of those. So now I want to talk about vulnerabilities. This is kind of the meat of the talk. And I think I have about 6 or so vulnerabilities I want to talk about. And we're going to go pretty quick, but on each one I have links to write-ups about them. I have links to the source code. I've got a couple live challenges ready to go if they don't mess up. If I do mess them up, I still have slides with screenshots. So the first vulnerability I want to talk about is CV 2022-1388. This is the first thing I worked on at Rapid7, and I'm just going to click on my analysis to show off. If you want to read this, I have a lot of detail about how it works, including assembly, including proof of concept. Like I wrote a lot about this. But I'll give you this sort of 50,000 foot view. If you're interested in seeing more, that's cool. If you can't read the terminal text at the bottom, that's just a screenshot from the page I just showed you. So you're absolutely welcome to just read it yourself. Basically, F5's big IP device was vulnerable to a authentication bypass. And that's a pretty common vulnerability class because it's really easy to mess up authentication. So the way their authentication works, currently even, like to this day, basically there's the F5 server. I drew this as 2 different servers, but really there's 2 services running on one server. The first service is a reverse proxy. The reverse proxy would do some types of authentication, not others. And then there's a backend that runs on localhost, and that does a different type of authentication, but not the others. So like whether you're using a password versus whether you use a token are handled by different services, which is a really strange way of doing things. I'm sure it's historical reasons ultimately. But what happens then, if you authenticate with a token, so you'll see at the bottom, I send xf5 auth token equals blah, blah, blah. If you authenticate with a token, the reverse proxy sees a token and says, I don't know how to do tokens, that's not my thing. I'm going to forward this on to the backend. So when the backend receives it, it goes, is there a token? Yes. Okay, I'm going to authenticate this token, and if it's wrong, I push back. If it's right, I accept it. Sort of simple. The backend does the auth. The second path for authentication, there's more than 2. There's like 3 or 4 different paths. It's just ludicrous. But the second way is if you say username and password as an authorization header. If the proxy sees username and password, the proxy goes, oh, this is my job. I should validate these. and it uses a PAM module, so it uses the Linux authentication mechanisms to validate this username and password by itself. And if they're correct, it removes the username and password and it forwards it to the backend. If the backend receives something with no authentication, it goes, oh, this must be already authenticated, and accepts it, which makes no sense, but that's how it's done. So if the backend gets something with no token and no authentication, it accepts it as valid, which that's bad. So it turns out, and I didn't know this, this was new to me, there is an HTTP header called connection, which I was aware of, which usually has the values of keep alive or close. Keep alive means keep the connection open, close means don't. But it turns out there's a third value for it, which basically says a list of headers that are the name of the header to be removed. So you can tell a proxy to remove a header while proxying. So now what you have is the same scenario, except now you send the X5 auth token as a connection header. The reverse proxy gets this authentication. It says, is there a token? Yes, there is, so I'm going to forward this to the backend. Then Apache's mod proxy says, oh, hey, I'm supposed to remove this token. So it removes the token and it forwards it. And then you win. The backend thinks you're authenticated. And there's a endpoint that you can't really see probably, but it's called tm/util/bash, bash bash, which takes the command to run. So you just run ID and it tells you root. So this is like remote root just by removing a header. And I thought that's a pretty cool vulnerability to like learn from, because like this whole connection header thing, I had no idea. I spent like a week trying to find the actual core issue of this vulnerability and couldn't figure out why it worked until I read the Horizon 3 is the one who disclosed it. Until I read Horizon 3's disclosure and they mentioned the connection header and I was like, oh, today I learned. So I made a challenge for BSides San Francisco 2022, which was 2 months ago, give or take, called Refreshing. And I posted a source to all these things. So if you want to see these challenges, we open source all of our BSides challenges, so you're absolutely welcome to see how we wrote them. But basically, I wrote a web application firewall reverse proxy that if it saw a query string with any weird characters, it would add a security header and say, this is a dangerous request. And then on the actual server, it would check for that header and say, if this header is here, alert, 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 this is bad. So I made this challenge, and if the user could remove the header, then they could path traversal in this case, do a very obvious path traversal attack. So basically the solution to it was just to curl and then set that header. And I thought that was a really cool way of teaching, because I had never heard this before. And I think anyone who solved that challenge probably learned something, because, I mean, some people I'm sure know that, but I sure didn't. So sometimes RFCs have weird edge cases. I think Brandon's really good for that. He'll dig into like file formats, like the zip or RAR format or something, and look for like weird ways of hiding data. So it's a cool type of challenge to like look at specs and make a challenge based on them. So that's the first issue I want to talk about. The second one, and this is kind of a 3 for the price of 1 thing, and I do want to do these ones live-ish. I have screenshots if they don't work, but I could go through this a little bit live. So this is from Holiday Hack Challenge 2020, which me and Daniel worked on. And this was our 2 calling birds. You see there's a bird that's calling, cell phone. And I can confirm owning a bird, they love being on my head. So the artist, it was a good rendition of what a bird would do. So basically, if you haven't played Holiday Hack Challenge, it's like a game. You hop around this virtual world, there's talks, there's music, it's just a whole game, which my old company, CounterHack, and Daniel can confirm, they put so much time, effort, money into making this free game just because our boss, Ed, just loves the Christmas challenges. And it's really, really cool that we do this for the community. Like I'm a very cynical person when it comes to advertising, and I think this is a super cool thing that Sans does and doesn't have to. But anyway, one of the things was to open the door of a room, and we have what are called terminal challenges in this game. And the terminal challenges will give you like a little console like this. And the consoles will let you run commands and do stuff. And this is like a legitimate URL. You could use this later. If you do use it, there's a username parameter that you should change to something else. Because if somebody else uses the same username, it'll kick you out, which is kind of funny. That's Daniel's fault, by the way. Anyway, you're given this terminal and saying, like, please reverse engineer this encryption to open the door. Now, something I believe strongly in is that reversing should be easy as possible. And often it means thinking the dumbest thing that might work. So the 3 different challenges, the first one is the door. And another lesson for making CTFs is hints. So like, I don't just give a challenge, you look at a screen and wants a password, you roll your eyes, the password's probably stored right in the binary. Giving those kinds of hints to people, I think, are very valuable, because you don't want people floundering and like doing guesses. So if you enter the wrong thing, it's just going to time out. Control C, yeah. So if you just run strings on door, typing is hard. If you run strings on door, you get a bunch of strings, and one of them is the password. I think I could just guess for the password. Yep, the password is open the door. So it's a very simple challenge, but you wouldn't believe how many times during an actual assessment of a real application that's worked, where I've just run like strings in a binary and gotten the password, a private key, something out of it. It's something that everyone should try. Like if you're going to reverse a binary, if you're trying to figure out what binary or an exe file does, if you run the Linux strings program on it, you might just find something. And if you don't, you might get interesting information. I think strings-l is helpful to get less junk. -n, sorry. I know how to do this. I'm a professional. That just gives you only longer strings. And like seeing what libraries are imported, stuff like that is really valuable. I should also mention, I can't talk in detail about the source of these ones because these are from like pen tests. But like, if you were to Google these things, you would realize this is written in Rust. And knowing it's written in Rust does like tell you things about the application. I think the more interesting one of these was the lights. Let me go to the lab folder because I rewrite it here. So if you run the lights binary, it says you wonder how to turn the lights on. If only it's some kind of hint, then it says config file loaded. So, and select file is decrypted. And that's kind of the big hint, is that there's a config file. And this was a very, very, very close surrogate of a vulnerability I actually found in some customer software. So if you look at the config file, it's got some fields that are encrypted and prefixed with $, and some that aren't. Now you'll notice when you run the program, it says, welcome back, Elf Technician. So it reads from the config file and then writes to the terminal. This one, I'm going to edit it and just replace Elf Technician with the password. I told you I'm an expert. I know what I'm doing. All right, and then run it again. I messed up. There we go. So now it says welcome back, computer turn lights on. Now this was like an oddly common thing I found in local applications that have encrypted config files, is that it's very common for config files to have some plain text and some encrypted fields. And there's been several times where I've just swapped the fields. So it decrypts something and then shows it to me. Usually it's a name, it could be other things. This has actually worked on multiple different pen tests I've done, which is kind of cool. The third one's a bit too complicated to actually like do live, but I do have slides. So this was the first one, second one. Okay, that's what I want. So this one was based on a point of sale desktop application that I was working on long time ago. And this application was password protected, but I could view the file, but the file was encrypted. And it was written in Visual Basic, I believe, so I really didn't want to like reverse engineer it and figure out how to decrypt the file. So instead, we messed with it. I forget how it came out, but eventually I deleted the config file. And when I deleted the config file, it prompted me, and I can show that what that looks like. So I'll just cat the config file just so you see what it looks like. So it's got an encrypted password in it, just like before. If I remove the vending machines.json file and run vending machines, it would, config file is missing, please create a new one. Please enter the name, run, please enter the password, doesn't matter. And then, if you look at the config file now, remove it. Run, password, doesn't matter. Doesn't matter. Let's not remove it this time. If you cat it, it encrypts the new values. And what it turned out is that if I encrypted a whole bunch of A's, a whole bunch of B's, a whole bunch of C's, etc., it would eventually have patterns. So if you look at encrypting a whole bunch of A's, and this is very, very, very similar to the real vulnerability, and we get 9VBT, blah, 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 9VBT. Every 8 or so characters, it would repeat. And then if I encrypted another string, like say all B's, it would be 8 different characters, but it would still repeat. If I encrypted like 16 A's, 16 B's or so, you would see the first half's the same and the second half's different. So I do what I always do. I ran into like some sort of weird crypto thing, and I asked Brandon and said, like, what am I looking at? And he said, it's a poly-alphabetic substitution cipher. What that actually means is like I could build a lookup table. I can try, like, I could do 8 A's, 8 B's, 8 C's, 8 D's, etc. Figure out what they encrypt to, and then build a lookup table that would just go backwards. And like, there's a much easier way to do that, but that was the hard way, and it worked. The problem is this is a GUI app I was working on, so I had to do each one by hand and like get a pop-up box, and it was brutally slow. But I was able to decrypt the whole config file using that, so that was pretty cool. So I really wanted to like implement these things as CTF challenges because like I ran into these in the real world, and I thought they were really cool and wanted to like show them off. Crypto attacks can be really easy to implement in a CTF challenge because what encryption is doing is very obvious. It's keeping data confidential, or it's keeping data, it's keeping integrity of data. So like, an attacker can change it, an attacker can read it, kind of thing. The problem with crypto challenges is it's often hard to make them interesting. So I think making it kind of like a game made it kind of interesting. But it's often kind of hard to make these fun. But I think these ones were interesting to like figure out. The other problem is that sometimes they seem too dumb. Like people look at our CTF and go, no one would ever actually do this when you got it from a real piece of software. So next I want to talk about, this one's interesting because this was a vulnerability in a Diablo 2 server in, I want to say, 2006, 2005, when I was quite a bit younger. A guy I know at the time, his name was Evil Cheese, living in the UK, basically spent a summer reverse engineering Diablo 2 server and finding duplication bugs. And back in those days, if you can duplicate an item like the Stone of Jordan, which if you ever played this game you probably recognize, you can make like $10, $20 off selling one. These days you can make apparently 35 cents, so that's, you know, economy. But basically, he found a bug that he exploited and duped a lot of items and made a bunch of money, and then it got fixed. But I could not find any information. I actually I found on the archive, I found someone talking about a similar dupe by the same guy, but I could not find the dupe that he told me about. It's possible nobody's ever talked about it, which is fine. It's also possible I completely forget the details, I get it completely wrong, because this is from a long time ago. But I think I got this reasonably close to accurate. So basically the way Diablo 2 worked was on the right you have the equipment screen. The equipment is an array basically. Your helmet, I'm making this up a little bit, but your helmet might be 1, your left weapon might be 2, your armor is 3, your amulet's 4. Doesn't matter. What's interesting though is like when you sell something, it would sell from a certain position. So you sell your hat, it would say I want to sell item number 1. If you're selling your mace, it's I want to sell item number 2, and so on. The thing is, there's this weird index 0 slot that was used as a temporary buffer, or so my memory tells me, where it would copy the item to that slot and then sell it. But there's nothing stopping you from selling directly out of slot 0. So what you could do is sell item 0, buy it back, sell it, buy it back, sell, buy it back, and get multiple copies of the same item. And like this is my memory of how the bug worked. And maybe it's wrong, but if that's right, it's an interesting bug. So I wrote a challenge based on that called Bees Fight. Bees being like Beelzebub, like Diablo. It's my pun. You'll notice that the refreshing challenge was the F5 bug. Bees Fight's a Diablo bug. I make funny names. So this one I actually have handy, and I don't know if it's going to work out that well, but I do have screenshots if it doesn't. But this is a game I wrote. I've edited the source code a bit to make this like easier to show off. But it was just like a little text-based adventure game. You would like netcat to a port. It would give you all this stuff. It has commands. You run help. When I was young, these games were all the rage. You know, adventure and Zork and all that stuff. But basically, the way the bug actually worked, and I'll show you the code for it in a bit. You have an inventory, so I have blueprints, grass shield, pictures of cats. I have like 50 things that you can have, and I spent a lot of time making a very simple challenge. But if you look at your inventory, So you remember this. I have a grass shield, so I can equip the grass shield, like so. And now I've got a grass shield equipped. I can unequip my shield, and I can unequip my shield, and so on. So I can make as many as I want. Well, that's cool. Why do we care? And the thing I should mention first was like there's different areas in the game. There's a street, for example, so I can move to the street. And then from the street, I can move to the convenience store. Move one. There used to be like random encounters. I turned those off just so we wouldn't have to deal with it. So when you're in the convenience store, you can buy a thing called flag.txt for a lot of money. More money than you would ever hope to have if you actually play the game. Which is not true because I hacked it to have lots of money, so I can show you that, but that's besides the point. What you can basically do is unequip your shield, unequip shield, then sell the item. I'll just sell one, and so on. So it's really simple. You just like unequip, sell, unequip, sell, unequip, sell, unequip, sell, and you make tons of money, game money, not real life money in this case. And then you get the flag. So when you buy the flag, there's a command to describe things. I forget what it is because, yeah, describe. Inventory, describe number 4. And it will give you the description of the flag. So like, it's a simple enough challenge, but to me it kind of like captured the same sort of thing that this vulnerability had. This is going to be, yeah, you've seen that already. So this is the actual code for it, and the source code is, as usual, linked. So you can just look at the source code yourself if you want. But basically, and this is a vulnerability type that I've seen a lot in real software, where it checks if something is null. It says if not weapon, it does something. But then when you unequip it, it doesn't set a null, it sets a flag to false. And it's really common when people store data in ways that weren't thought out well enough to like use 2 different pieces of unrelated data, like whether it's null, what's equipped, and mix them up. That's kind of a state machine problem. So this is a thing I've seen lots. And I thought I'd implement it, and it made a cool challenge. You've seen all these screenshots already, you've seen all that. Yeah, so like it kind of honors this bug that I sort of remember from being a kid, which I thought was really cool because like a cool person in my mind disclosed it to me, and now I'm telling all of you about it, but it doesn't matter because this is like 20 years ago. So next one I want to talk about, this was a bug called, we gave it a name, it's called Web Exec. So me and my former coworker, Jeff McJunkin, who's not here, but he should be, me, Daniel, and Jeff worked together for quite a long time. We were doing a pen test on a client site, and what they asked us for was, here's our secure laptop image, can you get system on it? And we said, we could try. So we spent some time on it, and we eventually figured out that there's a Windows service that can be overwritten, and it was Cisco WebEx, and you can overwrite it with an arbitrary exe file because their permissions were bad, and then start the service as a user and get system. That was a nice, easy vulnerability to exploit everything, but the customer was using a whitelisting software. So if we just replaced the exe file, it didn't work. It would flag it as a changed file and tell us it wouldn't load. So that sucks. How do we make this work? So like at the client site, I was like, I wonder what this WebEx updater service is. That's a strange one. So I ran strings on it. You know, as I said earlier, run strings on things. I saw that it ran like create process as user, which means it spawns other processes. And I'm like, that's interesting. What's a spawn? And it turns out it spawns wherever you tell to. So if you just start the service normally, SC, that's Windows Service Control Manager, SC start WebEx service, and you set the 4th parameter to an exe file and the 2nd parameter to software update, it would just run that thing as system. Just like, okay, you want to run calc? We'll run calc. It's basically sudo with no password. Excuse me. I don't know why it worked like that, but it worked and it worked great. So we were able to like run a program as root, anything we wanted, or as system, anything we wanted. And that gave us the ability to run like a interpreter payload or whatever it was. Something would have gotten caught. And because of how it ran it, it wasn't caught by whitelisting. So that was really neat. So we were able to like do that. Actually, I think we used it to run PowerShell, and then PowerShell run our code. Something like that, I don't remember. So like we reported to the customer and said like, can we like tell people about this? And they said, sure, that's fine, we don't care. So we got permission, so we went home and we wrote a report for the customer and we sent it. And we were documenting this vulnerability when Jeff says, can't you access the service manager remotely? So I'm like, huh, So then I ran sc // set my p address, and then like start Webex service. Sure enough, it worked. Suddenly we had like an authenticated sort of remote vulnerability. And it was really cool. We gave it a name because it was our first vulnerability we found, so we called it Web Exec, like Webex but exec. And like we did a pretty detailed blog about it. I linked everything, like I said, because I think it's lots of things to read afterwards. This is on my blog. So like I wrote that. I did like a high-level write-up. It's a full disclosure thing. It's what I do now for a living, but this is like doing it as a pen tester, as like we found the thing on a engagement. So we sent it to Cisco. They fixed it. They sent me the fix. I said this fix doesn't work. This can be bypassed. They published it. We bypassed it. They fixed it again. Blah blah blah. Eventually got fixed right on like the third try. So that was that. We also wrote a Metasploit module for it, and this is like my first ever Metasploit module before I worked at Rapid7. We just recently published my first post working at Rapid7 Metasploit module. So it basically runs. You give a username and password, and it runs code a little bit like SMB exec or whatever it's called. My brain just turned off. But basically like a PS exec, that's the one. It's a lot like PS exec, except not. So at the core, the whole problem here was bad Windows service permissions. I mean, badly designed software, yeah, but bad service permissions as well. So arbitrary users shouldn't be able to start a service, locally or remotely. Only system should start the service. So I was like, hang on, I can write a bad Windows service. So I wrote a bad Windows service. This is my README for it. I did not link this because we never deployed it. The README says, it says tricky to deploy, run this manually, after an error, blah, blah, blah. That was not good. So we tried to get this stable, and thankfully in testing, Windows Service Manager really doesn't like being a CTF target. You have to give people a username and password for the Windows machine. They have to not abuse the username and password. It's really easy to DOS it by accident. It's impossible to debug errors. Sometimes Windows Service Manager says like, So like it became really difficult, and thankfully we never deployed it. We did make a similar challenge for NetWars. I think Daniel actually got to work, but it's a late enough level that only like one person per game gets to it. So that it kind of works for that, but it never worked well for us. So I thought it was a really cool service, but it just didn't work. So like it turns out some platforms suck for CTFs. Like Windows SMB stuff is really, really bad. It's easy to denial service it. It's easy to like break things. In the cloud stuff has similar problems. If you're hosting on like, if you're relying on cloud-based challenges, which we do for BSides, it can be really tricky because the Google, Amazon, whoever might detect bad activity and break your service. Also, it's really easy to like mess up configurations and like blah, blah, blah. So yeah. More Battle.net. So like I obviously started with Battle.net as like my target. I think I have 2 or 3 more vulns and I have 22 minutes, so I think we're doing pretty good. So this goes back again to like 1999, 2000. And this is when I was first learning how to do like reverse engineering hacking. I joined like a group called Valhalla Legends, VL, who like I learned a lot of stuff from as like in like game hacking. They wrote a bunch of like cheats for StarCraft that they kept private, and they could do a lot of cool stuff like stack buildings and crush buildings, and like they wrote AIs that would like make the units do things. It's all really cool stuff, and I really wanted to learn as like a 18-year-old. So when you open up StarCraft and click on Battle.net, a bunch of stuff happens. It connects to Battle.net servers. It says like, hey, I'm from this I'm from this country. I'm running this version. It does a bunch of stuff like that. The first thing it does in Major though, it'll check the main program files, the exe file and the DLL files, to make sure they haven't been tampered with. And we'll talk about that. That's what this is based on. Then it validates your product key. It makes sure it's not used. It does a bunch of weird math that I bet you if I looked at it now it would make more sense. Back then I didn't understand it. We call it decoding the CD key. I don't know what it does, but I bet you I can figure it out now. And then there's a password hash. The password hashing we call broken SHA-1 because it's SHA-1, but not. They made mistakes implementing it. So like, I personally reversed all these things as like a brand new person, and I learned a lot about it. And I wrote like some of my old docs and others' docs that you can take a look at if you want. But the cool part was the version check. It was called check revision. Basically, when you logged in, you would send a Battle.net like, hey, I'd like to log in, please. I'm from this country, blah, blah, blah. It would say, sure, we're going to send you a DLL file, like a literal Windows DLL file. that we want you to load in the memory and then execute. So you would just download the DL file over plain text, load the memory and execute it. That's terrible now, but that's how it was done in like 1997. So the DL file would get a formula that was hard-coded, and it would always change. Like each time you do this, it would be different. But the formula would look like this. The first line's, the second line is more realistic, but the first line's a demonstration. A equals 5, B equals 10, C equals 15, and then A equals A plus S, blah, blah. It would send you that formula, and I was like, what's this doing? Like, I had no idea. And like what I learned from reversing and from like just testing was it would take each byte in the main DLL files and the exe file, set S to that byte, and then run this formula. So it would take whatever A was, starting at 5, and add S to it, and then do all this math. It would do that for every byte in the file. First byte, second byte, third byte, fourth byte, in the files on the operating system. And based on what you sent it, it would know what version you're on and be able to send you patches or whatever. So we reversed that. That's all out there. It's easy to find. But sometime, I forget when, like 2005, they changed it. They changed a thing called lockdown. And I reversed all of lockdown, and somebody else I know did too. And I can't find any of it running a sock. I have a wiki. This is my wiki right here. Oops, can't click on things. This is my wiki. I have a bunch of links, all 404. I have source code. It's not implemented. Arda, who's a little friend of mine, said we fully intend to update this in 2007. So like, all the work I did on this is completely lost to the void. I did find one source that talked about it, which is a white paper style, but it's a guy I know called Skywing. He works. Last I checked, he worked at Microsoft. That was a long time ago. But he kind of documented this whole thing, and it's really interesting. But all the work I did is just gone. I have no idea what happened to it. It's really sad. Like I wish I'd been on GitHub or something, but in 2007 it didn't exist. So I was really sad that I couldn't find this to show off. But what Lockdown did that was different was instead of fingerprinting the files on disk, it would fingerprint the files in memory, and it would use a bunch of anti-debugging tricks to make it harder. So the nice thing about doing it in memory is that when you check something in memory, debug breakpoints and things like that will change the checksum. So it's a much more complicated thing to actually bypass. So I wrote a challenge based on that called Secure Asset Manager. Secure Asset Manager is from BSides San Francisco 2021. As usual, the source is linked. Basically, you connect to a service. It sends you a string that's not unlike that challenge string you saw. You do a checksum on memory based on that, and then send the checksum back. So it basically does the exact same thing. Yeah, debugging, breakpoints, stuff like that will change the response. That makes it really hard. A lot of people think they got it solved, and then it doesn't work. It turns out it's because they were using a debugger and it broke. So yeah, I think I implemented all the stuff I found tricky about reversing it without anything that was actually the code. That was the first thing I reversed and I hacked. And I really want to shout out people. And I've done this same challenge in like 3 or 4 different iterations where I try to do like the challenge I remember having with this and then doing it again. So like I thought it was really cool. I learned from this. I want others to as well. So this is the last vulnerability, and it's by far my favorite one. So you probably heard Pokemon. I think Brandon's playing it as we speak. And there was a vulnerability in Pokemon Red back in the old days. And it was called the old man glitch. And the way it worked was you would go to a cutscene where the old man, the character in the game, would show you how to work a Pokeball, which you throw at things, is my understanding. I haven't really played these. And then you would just wander off to a place, I think Cerulean Island or something, and you go waiting, like on the right there. And then you would run to a Pokemon that doesn't exist, Missing No, or others. But what's going on here? Well, this was an old issue that like everyone who played Pokemon on Game Boy knew about. And it's called the old man glitch. So what's basically happening is when you talk to the old man, your name, like if I name a character Ron or whatever, your name is replaced with old man temporarily so they can like show you how to play. The problem is, this is from like, when's Game Boy? Like 1995? I don't know. It's from the 90s anyway. And it needed to store your name somewhere because there's no like heap, there's no way to like temporarily store your memory. So it would copy your name to somewhere that's not currently being used, which was the encounter data table. Which means that next time you have an encounter, if the table is never reset, it would just have an encounter based on your name rather than what you're supposed to. And as a result, you can have all kinds of broken encounters. You could, based on your name, you could change the level, the type of Pokemon, the IVs and EVs and Poke things. Brandon's cringing about my Poke knowledge. Cinnabar Island, not Cerulean. So yeah, basically it stores your name in the encounter data. So whatever's in memory, this is the use after free ultimately, is what is really known as. It copies anything in memory and then uses it for the wrong kind of thing. So I made a game based on this. On the left is the original Poke map. On the right is my map. This is an example of putting way too much work into a challenge. Let's see if I can zoom this right. Zoom. So this is the map I made. This is Google Docs. So I basically made this map, and I would export this to a CSV file, and then load it into the game. And it was really complicated, but it actually worked really well. So I could just design a map in Google Docs. And what's neat is I can modify the map. Like if I put trees in, I can put trees in. And if I export this and run the game, it will have trees there now. So I made all this. I also made a list of Pokemons. So this is the actual Pokemon names. Sorry, Game Freak, if I'm violating copyrights. But like Bulbasaur, Ivysaur, Venusaur, Charmander, I got all these from the wiki. But then for copyright reasons, and because for humor reasons, we changed them all. My husband actually did all this work. He changed Bulbasaur to Plant Frog, and Venusaur to Plant Dinosaur, and so on and so on and so on. If you play Pokemon, you know how much work you put into this. It's 152 technically because of missing no. And he put so much work into that. I put so much work into this map, and then I still had to write a game that was vulnerable. So here's what the game looks like when you actually play it. I'm gonna be Ron. The actual vulnerability is a bit too hard to show off, but I will show you the exploit for it in a bit. So I'm gonna choose Plant Frog as my starter. We have artwork. Might look a little better if it's small. It can also be Fire Lizard, not to be confused with Charmeleon, whatever. I'm not a Poke guy. There's also a small vulnerability in this, which doesn't really matter, where you can choose any Pokemon. So you could do Fire, you could do Missing No, I think, Dot, which is just this is an Easter egg, this is not actually useful, but you get Missing No. So once you start the game, you get to walk around the game world. The goal of this game, and it says it somewhere, is if you can collect all 151 Pokemon, which is in this list, or see all 151 Pokemon, then you'll get a flag, basically. And it just occurred to me, completely randomly, that the professor is actually based on Jack from BSides, Jack Daniel, Professor Jack, which is kind of funny. I just did it as a joke, but it kind of works here. We had the whole world, you just on the spreadsheet. It's all the names and all the locations and all the encounters are all done. There's fights. All the math of the fights is based on the actual Pokemon math. It's all way too much work went into this. There's also I forget what the command is. There's hidden commands. It's this really complicated game for reversing and for playing. Now the actual vulnerability in this. Let's see if I can find my slides. Talked about that. Oh yeah, use after free. There we go. So it's basically, this is way too small. I use after free in the capture thing, where if you capture a Pokemon and then free it, you end up with a pointer to uninitialized memory, and you could, by using a name changer, change your name to be put into that memory, which is like a weird heap attack. The actual file doesn't really matter. I did a very detailed video about it, which is linked right here. But I also wrote an exploit for it that I can show off, which this is a 1 second per move delay, but you can see how it wanders around. It's going to take forever to do anything. Let's go 0.3 seconds. So I also use there's hidden teleport commands. It knows how to do fights. It knows how to do all this. Like I said, I spent a lot of time on this. Everything it's doing is for a reason. That's a name changer. I'm not going to make you watch this in that speed. I think 0.04 was what I was using to test it. Basically, it uses the encounter table vulnerability to use your name to overwrite the encounter table and be able to encounter things you shouldn't be able to encounter, basically. You'll see that the encounter table has hi as an encounter, which is not valid, in addition to the other names. So I can let this run. It probably won't finish by the time my talk's done, but it will eventually log all 151 Pokemons and then win the game. Yeah, so this is not identical to vulnerability, but I think it captures the feeling. Like, I think the whole, like, using your name, use after free, all those kinds of things are kind of captured. And, like, this is by far the challenge I'm most proud of, because I put tons of work into it. But, like, there's a line of Futurama similar to, or something like that, similar to but legally distinct from, that I use a lot. And I was told not to say legally in my talk. So, similar to but technically distinct from is similar to but legally distinct from, similar to but legally distinct from. But anyway, so that's that vulnerability. And that's kind of the last part of my talk. I just had this one slide as a conclusion because I felt like if I said nothing else, it would be kind of too soon. Basically, there's some bugs that we find that are very teachable moments. The F5 vulnerability, where I learned about headers and stuff like that, are very well teachable moments. Some bugs you find that you can't talk about because they're in customer stuff, but you do want to talk about. You can often find ways to get around that and do like challenges based on those. Some bugs are just too hard to implement. Like, I wasn't going to implement the Diablo 2 server, but I could make a server that behaved like the Diablo 2 server. And then some bugs just don't work. We talked about Webex. That's pretty much it. There's a tiny URL at the bottom there where you can get these slides. The QR code will take you there, I promise. My Rapid 7 work is at hackerkb.com. I seriously think that HackerKB is the coolest thing I've ever worked on. I get to just write detailed stuff about vulnerabilities, and my coworkers can confirm this. We just like spend days researching a vulnerability and writing about it, and I think it's really cool. My blog, which I mostly use for CTFs now, and my email addresses. So I don't know when I have to be out of here, but I might have a couple minutes for questions. I'm told I have 2 minutes. If anyone wants to know how the oh, we're up to number 32, so this will never finish. 33. Thanks everyone for coming, and have a good rest of your Vegas.